Good morning, everybody. Happy Wednesday. Welcome to another video. In this one, we're jumping into another method of solving a system of equations. So there are three methods we're going to look at. The first was graphically, using your graphing calculator or just looking at a graph that's down on your paper. The second one we're going to look at is called substitution, and this is an algebraic method or kind of one we can do by hand. So we'll dive into this one and get to some homework. So let's jump in. Here we are, page 627, jumping into solving by substitution. So this method is how I can solve a system by hand, right? Just doing some algebra, kind of rearranging and finding a solution. So it actually outlines the method right here, and we're just going to kind of dive in, and I'll read it, but then it'll make more sense when we actually solve. Okay, so it says step 1 for substitution. Choose the simpler equation and express one variable in terms of the other. Okay, so what that means is I need y equals something or I need x equals something. Okay, it can't be all mixed up. I need specifically a y equals or an x equals. Okay, number 2, substitute the expression from step 1 into the other equation. Okay, we'll talk about that as we do it. Then it says solve the single variable equation. All right. And then it says substitute the solutions from step 3 into the equation in step 1 to find the value of the other variable. All right, well, I don't know if that makes a lot of sense just reading it. Let's actually solve. Okay, so question 1, we're going to do the same question twice actually, and I've got it all spread out. You'll have to write really small to squeeze it in. Okay, solve the system using the method of substitution by rewriting the first equation to form x equals. So whenever I do substitution, I'm going to start by labeling equation 1 and equation 2, because throughout this process, I'm rearranging and I'm making the equations look different, but I always want to remember this is equation 1, this is equation 2. Okay, so step 1 of substitution is choose the simpler equation and express one of the variables in terms of the other. So what I'm looking at is between these two equations, could I easily get one of them to be x equals or y equals? Okay, and there are easier ways and there are harder ways, and we'll see that in a couple examples. I am doing substitution because I can pick the easiest one. Okay, in this one it says, well, take the first equation and rearrange it to x equals. Okay, we'll do that. So equation 1, x plus 4y equals 17. If I want to get x all on its own, I would subtract the 4y, x equals negative 4y plus 17. Okay, that's good. That is still equation 1. Keep in mind, I'll label it. It's the same equation I have up here, I just rearranged it. All right, step number 2 was substitute the expression from step 1 into the other equation. So what I'm doing, this is where the name substitution comes in. This right here, I'm going to move into equation 2. Okay, 1 goes into equation 2. So equation 2, just for reference, was 2x minus y equals 7. What I mean by substitution, what I mean by this whole process is equation 1 tells me this statement. I can plug that into that statement because it says x is negative 4y plus 17. So instead of writing x, I can write negative 4y plus 17. So that is the substitution it's talking about. It's I rearranged one of the variables in the first equation, and now I can sub it into the second. So it's always I take one of the equations and rearrange it and put it in the other. You can't put an equation back into itself. So I am taking that x, but instead of writing x, I'm going to write negative 4y plus 17 minus y equals 7. I have substituted in. And now if I look at this thing, I actually only have y's. So this is step 3, solve the single variable equation. Because I substituted for x, I plug it into the x, with just the y's. So now this equation is a single variable and I can solve. Okay, it'll take a bit of work. I have to do the distributive property, get rid of those brackets. Negative 8y plus 34 minus y equals 7. Okay, well, altogether that's negative 9y plus 34 equals 7. And I'm working my way down solving. Okay, subtract 34 from both sides. I can solve algebraically. Negative 9y equals, oh, good grief, 7 minus 34. 7 minus 34, negative 27, and divide your coefficient. Okay, there we go. Y equals negative divided by negative is positive. Well, that would be 3, positive 3. There is one of my answers. Solving a system of equations, I need an x and a y, or I need a coordinate. I need that ordered pair. Well, I just solved for y. Okay, I just solved for y. The last thing is it says substitute the solution from step 3 into the equation in step 1 to find the other value. Well, let's just think about it. I have y equals. A coordinate pair has an x and a y. So if I already have y, I need x. And you say, I desperately wish there was some equation that told me, hey, x equals this. Oh, there it is. We already have an equation. We can plug in and say x is equal to negative 4y plus 17. Okay, so I'm just going to move my work up here. X equals negative 4y plus 17. And I already know y. So negative 4 times 3 plus 17, which is negative 12 plus 17, or x equals 5. Okay, so right here is actually an adequate solution. You have x stated, you have y stated. I'm done. If I wanted, like we're used to with graphing, I could write it as the ordered pair. But I don't have to. Okay, I absolutely don't have to. I can just leave it having boxed my x equals and boxed my y equals. All right, that is substitution. Pick the easiest equation to isolate a variable, plug that into the other equation. Now I can solve for one of my values, and then I take that and go back, plug it in to find my other one. Okay, that is substitution. All right, we're going to jump to the next page, and we're going to do the same exact thing, but we are going to rearrange the other equation. Okay, so I'm just going to write them out again. X plus 4y equals 17, and 2x minus y equals 7. Yeah. Okay. Same problem. Here's how we could do it a different way. I have equation 1, I have equation 2. It says, well, why don't we rearrange the second equation to y equals? And I say, okay, that's pretty easy because I just have to move the y over, move the 7 over. It's not that bad. Maybe not as easy as rearranging for x, but I guess I could do it. Okay, so I'm going to look at equation 2, which is 2x minus y equals 7. Start rearranging. Add y to both sides. 2x equals y plus 7. And subtract the 7. Okay, so you get 2x equals y. Nope, that's not what you get. 2x minus 7 equals y. And maybe you prefer to write it the other way. Okay, y equals 2x plus 7. All right. Okay. Now, that was equation 2. I need to take that and substitute it into the other one. So what I'm actually doing is 2 substitutes into 1. Okay, last time we did 1 into 2. Here we're doing 2 into 1. It's whatever I just rearranged back into the other one. So equation 1 is x plus 4y equals 17. And what I've rearranged is y. I can replace the y with 2x minus 7. I am substituting it in. All right. X plus 4 times 2x minus 7, that's my substitution, equals 17. And now I go through the whole algebra process just like the other one. Because now x plus 8x minus 28 equals 17. That's all x's. It's all x's. There's nothing to worry about. Okay. 9x minus 28 equals 17. All right, add that 28 to both sides. Add that 28. 9x equals 45. Divide by 9, divide by 9. And you get an answer of x is equal to 5, which is a really great answer because it's the answer that I got on the page above. Okay, it's the answer I got using the other method. All right. Okay, well, now that I have x equals 5, I'm going to go back and I'm going to say coordinate pair. I need the x and the y. Luckily, I have this beautiful statement that already says y equals. All right. So I'm going to say y is equal to 2 times that x value minus 7, or in this case, 2 times the 5 minus 7, which is 10 minus 7, or 3. Hey, I got the same answer. I don't even have to write the ordered pair if I don't want to. I did it. X is 5, y is 3, the same exact answer I got above. All right? So that is just to show you actually have a choice. So when I ask you to do substitution, when I give you a question and I say, hey, you need to show me this algebraically, you have a lot of choices. You could rearrange for the x, you could rearrange for the y. Oops, I didn't mean to be drawing. Okay. Or I could have rearranged for this y. It just would have been awkward because I'd have to divide by 4 and I'd have a fraction. Or rearrange for this x, but I'd have to divide by 2 and have a fraction. So it's about picking the easiest variable to rearrange to, and then you sub in and you go through. Okay. Let's verify. Okay, it says verify the solutions satisfy both equations. So I'm just quickly going to say, all right, x is equal to 5, y is equal to 3. And remembering, equation 1 said x plus 4y has to equal 17. So my x and y have to satisfy that. And at the same time, equation 2, 2x minus a y has to equal 7. So I am proving that these x and y values work for both equations. Okay. 5 plus 4 times 3 is supposed to equal 17. And it's like I have a wall going down. I'm just simplifying this side down. I'm just simplifying this side down. Something new, I don't think I showed this yesterday or the day before. 17 is not simplified or cannot be simplified even further. So I'm going to stop writing it and I'm just going to do the other side. 5 plus 12 simplifies to 17. Then you say, well, this is simplified down. It's the same thing I stopped writing over there. I will write this. Left side equals right side. That's good. Okay. Same thing over here. Okay. 2 times my x value of 5 minus your y value of 3 is supposed to equal 7. I'm not going to write the 7 anymore because it's already simplified. 10 minus 3, that equals 7. So I simplified this down. That's already simplified. My left side is equal to the right side. They're the same number. So I know I have the correct answer. Okay. So no matter what method we use, whether it's substitution, whether it's graphically, whether it's the method we're going to learn tomorrow, I can always check my answer by going back to the original and plugging in my values that I think are correct. Okay. Last thing, it says check the solution using a graphing calculator. Okay. X plus 4y. X plus 4y equals 17. 2x minus y equals 7. Well, if I was going to do this on my graphing calculator, I need them to be in the form of y equals. So I'm going to do this. Okay. I'll show my work over here because I have space. X plus 4y equals 17. 4y equals negative x plus 17. Y equals negative a quarter x plus 17 over 4. Okay. Y1 equals negative 1 quarter x plus 17 over 4. So that's a fast rearrange just because I don't really actually want to do this. This one, we already did this. y equals 2x minus 7. Okay, we did that for part B of this question. Okay, so as long as I can rearrange these to y equals, I can graph them on my calculator, right? So yeah, they started like this, but if I turn them into my y1, y2, I can graph them on my calculator. So get rid of whatever I had, bracket -1 divided by 4, bracket x, plus bracket 17 divided by 4. I just put those fractions in brackets. Okay, 2x minus 7, that's y2. Let's go zoom 6 for zoom standard. First one, second one. Now I have to find the intersect. So second calc, 5. So I can scroll down or I can just press the number 5. First curve, yep, I'm on the blue one. Second curve, yep, I'm on the red one. Make a guess. I go pretty close, doesn't have to be perfect. Hey, would you look at that? X is 5, Y is 3. So I could do this graphically, or I could check my answer graphically. Okay, I can do this algebraically, and I can check my answer algebraically. Okay, so something to keep in mind is as we're learning these methods, on a written question, I can say, do this with substitution, do this with your graphing calculator, do this with elimination is the new method. On a multiple choice question, pick whichever method is easier, right? And as we learn the methods, we're going to see which is easier or which is harder. So sometimes it'll be easier to just do it by hand. Other times it'll be easier to graph it on your calculator. Okay, let's do another one. Okay, here's this a system. 4x plus 3y equals 0. 8x minus 9y equals 5. Okay, solve and verify the system using the method of substitution. So it's telling me I specifically have to do substitution. I have equation 1 and equation 2. My goal is to make it the easiest possible rearrange. So I need to solve for x equals or y equals. What I'm looking for, ideally, is no coefficient. So if I just had an x, I'm going to rearrange for that. I don't. They all have coefficients, which means I'm going to have to divide, and I'll probably end up with a fraction. Okay, well, that's not ideal. So then I say, well, which has the least amount of stuff around it? Equation 2 has 3 pieces. So if I were to solve, I'd be dealing with 3 pieces. I'd be dealing with multiple fractions. Equation 1, really, you have your 4x and 3y, and then just a 0. So that's not really going to affect anything. So I am going to rearrange equation 1, and I am going to solve for x. Okay, doesn't matter. I can solve for x equals, I could solve for y equals. It does not matter. We're going to get the same answer at the end of the day. But whatever, I'm just deciding I'm going to solve for x. So I subtract the 3y, get that away. 4x equals negative 3y, divide by 4, divide by 4. Okay, so you get x equals negative 3/4 y. Great. So I have fractions. Ideally, I pick the easiest method, which does not give me any fractions, but I work with what I have. So I'm going to take that as equation 1, and I'm going to plug it in to equation 2. Okay, plug it into equation 2. Equation 2 being 8x minus 9y equals 5. That's equation 2. And the substitution I have is, hey, x, don't write x, write negative 3/4 y. So I have 8 times negative 3/4 y minus 9y equals 5. Okay, and I need to solve. So I'm supposed to do 8 times negative 3/4. That's going to be my coefficient. Let's say I don't want to do that. Luckily, I have a very nice calculator. 8 times negative 3 divided by 4, is negative 6. Negative 6y minus 9y equals 5. Okay, or negative 15y equals 5, and divide that away. Okay, so you might say y equals negative 5/15, but we always reduce our fractions. that reduces to 1/3. Hey, so I got a fractional answer. Great, that's totally fine. Okay, I take that and I say, okay, I have y equals, I really wish I knew x, because I know a solution to a system, that's an xy, it's a point. I have this beautiful equation that tells me what x equals. It says x equals -3/4 times y. So in this case, -3/4 times -1/3. Well, negative times negative is going to be a positive. Multiplying fractions, you go top times top, bottom times bottom. 3/12. Again, always reduce my fractions. 1/4. Okay, so speaking on the method, this question was identical and exactly as easy as the first two examples we did. Practically, because I'm dealing with fractions, it's harder. So substitution, in my opinion, is great when I can avoid fractions. When I can't avoid fractions and I have to deal with the fractions, I would probably prefer to just do this graphically or with the method that we're going to look at tomorrow. But it's possible. I can solve for x, I can solve for y. Okay. It says to verify. Okay, it says to verify. And then it says to check using your graphing calculator. Okay, well, graphing calculator, I would just rearrange to y equals, and be good to go. I'm just going to verify. Okay, equation 1 was 4x plus 3y equals 0. Okay, 4x plus 3y equals 0. So 4 times 1/4 plus 3 times -1/3 is supposed to equal 0. Let's check that all the way down. 4 times 1/4 is 1. 3 times -1/3 is -1. So 1 minus 1, oh yeah, 0 does equal 0, we're good. Okay, the other equation was a bit more complicated. 8x minus 9y equals 5. Okay, well, 8 times 1/4 minus 9 times -1/3. It's supposed to equal 5. The 5 is good. Let's just simplify the left. 8 times 1/4 is 2. -9 times -1/3 is positive 3. 2 plus 3, 5. Oh yeah, left side equals right side. I'm good. So I verified algebraically. I know I have the correct answer. So this is not part of the question. This is just me checking if I have the right answer or not. You could do it all the time. Sometimes I'll ask you to do it, or sometimes we'll think about it, but this is the solve. This is just me checking. All right. One more. We're going to do one more with substitution. So here are my two equations. 1, 5 times 2a minus 3 plus b equals 5. 6a minus 2b minus 4 equals 20. Okay, those are my two equations. Substitution, I want the easiest rearrange. The easiest rearrange. So for me, that would be solving for b. Because b is pretty much all on its own. A is tucked within a bracket and it's got the 2. If I distribute it, it'd be a 10a. No good. 6a, no good. This one's in the bracket. So b in equation 1 is what I'm going to start rearranging to. Okay. 5 times 2a minus 3 plus your b equals 5. Okay. And what I'm going to do is rearrange for b equals. So there's a couple ways. I'm going to say, let's move the b to the other side. So subtract b. 5 times 2a minus 3 equals negative b plus 5. And now I'll move the 5 over. Minus 5 minus 5. So you get 5 times 2a minus 3 minus 5 is equal to negative b. And that's not great. Okay, that's not great. I don't want a negative b. I want a positive b. But I remember, hey, I could just multiply by -1. And what I do to one side, I have to do to the other. So you get negative 5 times the 2a minus 3 plus 5 equals positive b, or this, negative 5 2a minus 3 plus 5. Okay. Or maybe you look at that and say, maybe an easier way to do that rearrange would have just been to move this whole chunk over. Whatever. Okay, I've rearranged for b. It's definitely a bit more complicated, but it's still possible. Okay. Now, this was equation 1, so I'm going to take equation 1 and put it in to equation 2. Take the equation you rearranged, put it into the other one. Equation 2 being 6a minus 2 times b minus 4 is equal to 20. So this is a big substitution. This is a really complicated question, but we can still do it. This is b. All of this is b. So right inside this bracket is what I'm going to replace. Okay, 6a minus 2 times negative 5 times 2a minus 3 plus 5 minus 4 bracket equals 20. So notice I replaced all of this in a bracket. That's b. I have to simplify that, and then I will move on to other things. So 6a minus 2. Okay, let's simplify this. On the inside, if I'm solving this, little distributive property, negative 10a plus 15 plus 5, and then I have my minus 4 outside of that, equals 20. 6a minus 2, you have negative 10a plus 20. Now I'm ready for that subtract 4 on the end, equals 20. So really, we're doing like a polynomials question. Okay, negative 10a plus 16 equals 20. All right, all I've done so far is simplify this bracket all the way down to here. That's great. Now I'm going to do this distributive property. Notice it's a negative 2. So 6a, negative 2 times negative 10a is positive 20a. Negative 2 times 16 is minus 32 equals 20. Okay, so I get 26a minus 32 equals 20. And let's go through and solve. Add 32 to both sides. Add 32 to both sides. 26a equals 52. And divide. A equals 2. Perfect. Hey, I was able to solve for one of my variables. So I know in this, it would be an ordered pair. It would be a and b. I already have a. Okay, I already solved for a. Now I'm saying, is there anywhere in this equation that tells me b equals? Yeah, right here, the initial equation I rearranged. I can take this up to some open space and say b is going to be negative 5 times 2 times that a minus 3 plus 5. And I plug in 2 times 2 minus 3 plus 5. Simplify that bracket. It's a BEDMAS question. 4 minus 3. B equals negative 5 times 4 minus 3 is 1 plus the 5. Negative 5 plus 5. Oh, your b value is 0. So a was 2, b was 0, and I'm good. Okay, there's the whole solution. Pretty big, lots of work, but ultimately it's doable. Okay, it says solve or verify. We don't really need to verify. We could do it algebraically, plug it into the original equations. We could do it with our graphing calculator. I'm not going to make you do that. Okay, so yeah, this was more complicated. Okay, these things are pretty wild. Honestly, substitution, probably not the best method for these. A better method would probably just be to graph them, rearrange them and graph them. But I can do substitution. Okay, so the first example is probably the best to look at for this method because this is more likely what you're going to do, right? Pick the easiest rearrange. Hopefully you don't have to deal with fractions. You just get an x equals or a y equals. Take that, plug it into the other equation or substitute it in. solve for whatever variable you get. And then nice and easy, I can go back. I've already rearranged an equation that'll tell me the other one, and I have my answer. Okay, so time for some homework. 1 and 2AB on page 629. And that is it for today. And that is it for the video. Another one in the books. So you got a little bit of homework today, and that's it. Okay, get the homework question done in your AVP. And as always, send a question in the form, set up a one-on-one appointment, smash the like button, hit subscribe, tune in again tomorrow, and we'll have another video.